video is on angles and polygons. And so the first thing we're going to do is fill out this chart here below of different types of polygons. So the first one is a quadrilateral, and it's got 4 sides. And we're going to try to figure out how many triangles fit inside the quadrilateral, which is 2. And we know that a triangle has 180 degrees, so if we take 2 times 180, we get 360. So the total interior sum of a quadrilateral is 360. 5-sided figure is called a pentagon, and if we make a pentagon here and then draw a diagonal from one vertex, I end up getting 3 triangles. So if I take 3 times 180, I get 540 degrees. So the interior sum of a pentagon is 540. A 6-sided polygon is called a hexagon. If I then draw from the same vertex diagonals, I get 4 triangles. 4 times 180 is 720 degrees. So now I'm going to try this with an 8-sided figure that's called an octagon. How many triangles fit in an octagon? Well, it's 6. So then if I take 6 times 180, I end up getting 1080 degrees. A 10-sided figure is called a decagon. So can you guess how many triangles will fit in a decagon? Do you see the pattern emerge? 8. So I hope you see the pattern here with the number of sides and the number of triangles that fit inside the polygon. A 12-sided figure is called a dodecagon. So let's see if I can draw a dodecagon here. Okay, leave yourself a lot of space. Alright, there's 12 sides. So it should be 10, right? 10 triangles? Yes. 10 times 180 is 1800. Alright, so you can see the pattern here. Whatever the number of sides, we subtract 2 to get the number of triangles, and then we take that and multiply it times 180 to get the sum of the interior angles of a polygon. So we take the number of sides, subtract 2, and multiply it times 180. So what is a regular polygon? Well, it's a polygon with congruent sides and interior angles. So in the second part of this, I want you to fill out the chart using some of the information from the previous page and then find the interior angle and the exterior angle. Well, we know a quadrilateral has 360 degrees and all the interior angles are congruent. So if I take 360 and divide it by 4, I get 90. And we know that angle X and angle Y are both going to be a linear pair because they form a straight line. So then if I know one interior angle, I can find the exterior angle by subtracting that from 180. Now I know I've got 4 congruent exterior angles. If I take the 90 degrees and multiply it times 4, I get 360, which is the exterior sum of the square here. So we're going to do the same steps for the rest of the polygons here. The pentagon has 540 interior sum. I divide it by 5 to get 108 as my interior angle. Subtract that from 180 and I get 72 as my exterior. Multiply that by 5 to get 360. We're going to follow the same steps for the rest of the polygons here. And then let's see if you can figure out if there's another pattern here on this page. So maybe you want to pause it and see if you can figure out these problems on your own, and then you can go back and check your answers. Now the only thing about this figure here, this 9-shaped polygon, which is a nonagon, is that we don't have this interior sum from the previous page, so we actually have to find it here by using the n minus 2 times 180 equation. But when you've finished the sheet, you should notice that all the exterior sums are 360, and that the interior angles and exterior angles are a linear pair and are supplementary. And the polygon sum formula we've already looked at before is n minus 2 times 180, where n is the number of sides. So let's take a look at example 1. Find the sum of the interior angles of an octagon. Well, we've already done this, but let's review it. We take the number of sides minus 2 times 180. So in this case, it would be 8 minus 2 times 180, which is 6 times 180, or 1080 degrees. Example 2, the sum of the interior angles of a polygon is 1,980 degrees. How many sides does the polygon have? So if we use the equation n minus 2 times 180 and set it equal to 1,980, we can solve for n. So the first step here is I'm going to distribute the 180, and then I can add 360 to both sides, and I get 180n equals 2,340. Divide both sides by 180, and I get 13. So this polygon has 13 sides. Example 3, how many degrees does each angle in an equilateral septagon have? Well, a septagon is a polygon with 7 sides. So I can use the interior sum formula, substitute 7 for n, and solve. So 5 times 180 is 900. But I want to solve for one of the interior angles. So if I know the interior sum, and I know that it's equiangular, or a regular polygon, I can divide it by the number of sides, which is, in this case, it's 7. So 900 divided by 7 is about 128.6 degrees, rounded to the nearest tenth. So the formula here for solving for one of these angles in a regular polygon is the interior angle equals n minus 2 times 180 divided by n. And then again, the regular polygon is a polygon with congruent sides and angles. Let's take a look at example 4. Okay, find the measure of x. Well, we know from our investigation that a quadrilateral has 360 degrees. So if I take each angle, add it up, and set it equal to 360, I can solve for x. So I need to add like terms. So I've got 8x plus 136 equals 360. Subtract 136 to both sides. Divide by 8. I get x equals 28. In example 5, I'm given all the exterior angles, and there are 5 of them. I know all but y. So we know that all the exterior angles of a polygon add up to 360. Doesn't matter what kind of polygon. So all I have to do is add up all of these angles and set it equal to 360. Y plus 235 equals 360. Subtract 235 to both sides, and I get y equals 125 degrees. And that's it. So I hope this section makes sense. Go and try the practice set.